Okay, we are moving slowly. Now it's part 10, and today we are going to discuss about visual acuity expressions. Expressions means, or basically, we can take unit but not unit but definitely. So, decimal visual acuity is fractions, Snellen's fraction, obviously, logMAR, VAR, what is cycles per degree, and a lot more. Okay, so let's discuss one by one. So, method of specifying visual acuity. First, we will discuss about Snellen's fraction. As we all know, Snellen's fraction is a basically express the angular size of the prototype, especially in distance, the height of the letter. It's definitely reciprocal of the mar. If we do reciprocal of the mar, that's Snellen's fraction. So basically, it is written as the testing distance in the numerator and letter size in its denominator. See, testing distance in the numerator, but letter size means, let's take an example, 660. It's not means 60 meter or whatever. It means that letter size which substance 5 minute of arc in total, or letter size which mar will be 1 minute of arc at 60 degree, at 60 meter, sorry, 60 meter. That means 660. 612 means the letter size which substance 5 minute of arc in total at 12 meter, isn't it? That's it means the letter size in the denominator. Letter size means the size of the letter which substance 5 minute of arc at that particular distance, not at 6 meter. Six means that testing distance 6 meter and its substance 5 minute of arc at 6 meter. 5 minute of arc means whole letter, not the mar. Mar is 1 minute of arc, obviously. So decimal notation is very simple. Okay, it's just Snellen's fraction. You just divide it. Simple Snellen's fraction. You don't have to. If you invert it like 660 by 6, it means 10. It's a mar, isn't it? Sometimes decimals fraction is 1 by mar. It's also shown like that. It's very simple. Okay, very simple. It is proposed by actually French ophthalmologist, which is Ferdinand Monnoyer, but I have kept his name because many of the students don't know this fact that he is also father of diopter, that unit of the optical power. So someone asks you who is the father of diopter, so it's that French ophthalmologist Ferdinand Monnoyer. Okay, so it's decimal system. Decimal system. Let's move further. Minimum angle of resolution. So minimum angle of resolution, I hope you come to the uh, good terms with the minimum angle of resolution, because minimum angle of resolution is a expresses minute of arc. Basically, we know minute of arc, isn't it? So 1 degree divided into 60 parts, then one part is known as 1 minute of arc. Indicates the angular size, critical detail within the just resolvable optotype. What do you mean by angular size? Angular size made in nodal point. Okay, that's important point. For letters, critical details is taken as 1/5 of the letter height. Okay, 1/5 of the letter height, as I have told, in total it makes 5 minute of arc, but actually mar is 1 divided by 5 is 1 minute of arc. Mar means the detail, okay, that which we have to resolve. Mar is an equal reciprocal of the decimal value. I have already told you, isn't it? Mar is 1 divided by decimal, and at the same time, I have told you decimal notation is 1 divided by mar. We can think, or you can take mar just simply reversing the Snellen's fraction. If you reverse the Snellen's fraction, that's mar. Okay. So 2020 means 1 mark. 2200 means 10 marks. If you reverse the 2200, 200 divided by 20, which means basically 10 marks, isn't it? Minimum angle of resolution. Okay. Log mar, you just put mar into the log. Finished. It's basically this. Whenever we don't claim log, then we have to know that log base to 10, and if log base 10 and has the mar 10 in case of 660, then it means 1, isn't it? Basically 10 to the power 1, that's why it's 1. So log mar, you don't have to any worry about anything, just put log base 10 and put the value of mar here, whatever it comes, it will come as a result. Okay, that's simple as. Visual acuity rating, that's another factor. Why we use visual acuity rating? Because visual acuity, in case of MAR, see, in case of MAR, it's exactly logMAR, it's exactly opposite. If logMAR is 660 is 1. If logMAR 66 is 0. If logMAR 63 is 0. I think minus 0.15, I don't know. Okay, exactly. And whenever vision gets better, logMAR decreases, even comes in minus value. That's why we want such a system which creates positive value. As the vision increases, a vision gets better, var increases. Var is very simple, just remember this formula. Okay, 100 minus 50 into logMAR, whatever logMAR. If logMAR is 0, then var is 100. If logMAR is minus, then var is greater than. So as logMAR uh, decreases by even going minus, var increases. As the visual acuity becomes better, var becomes greater. So visual efficacy is a quantifying vision loss of the legal or compensation purpose. It's different thing. Okay. So considering to be 1 in decimal system, 100% 1 visual acuity 2020, and arbitrarily 660 means 20%. The percentage system was there, but it's not that much of use. But definitely in percentage system, visual efficacy used in a percentage system, but it's not used as much as we think clinically. Okay. So another point is spatial frequency and cycles per degree. It's very useful whenever you are seeing research in contrast sensitivity and visual perception is very important. Okay, so the unit is defined as a considering gratings of white, one white and one bright, isn't it? What do you mean by cycle? Cycles mean by white and black, isn't it? That's why one cycle. And as we know that 1 minute of arc is a resolving capacity of I, then this is 1 minute of arc and this is 1 minute of arc. In total it's 2 minute of arc. So one to make one cycle you need 2 minute of arc, isn't it? Okay, so just remember, just think, 2 minute of arc, sorry, 2 minute of arc is one cycle. Just do unitary method. Okay, what if 2 into 30 minute of arc is equal to 1 into 30 cycles? 2 into 30 means 60 minute of arc, which means 30 cycles. 60 minute of arc is eventually 1 degree, corresponds to 30 cycles. That's why we call this. See, in 2020 visual acuity, the resolution MR is 1 minute of arc, then 1 into 2, 1 black 1 white means 2 mar is equal to 1 cycle, and then we just make it to 60 minute of arc, isn't it? In 60 minute of arc, that's 30 cycle. It's just a calculation, simple calculation. Okay, just remember, this is the formula. If you want to put into the formula, just put into the formula. Formula is basically 60 divided by 2 into mar. That's finished. For example, if letter is 660, what do you mean by mar? 60 by 6, isn't it? Sorry, 60 by 6, which means mar is 10. Then just put it into the formula. 60 divided by 2 into 10. Done. That's 3. Finished. 3 cycles per degree, isn't it? It's just a simple thing. But you have to understand basic form. Okay. For example, if mar is 10 minute, then two of those mar, one black and one white, make one cycle. For one cycle they needed 20 minute. And how much if I multiply 1 here and 3 here, then it's 60, isn't it? So 3 cycles makes 60 minutes. 60 minutes means 1 degree. That's why 3 cycles per degree. That's the spatial frequency. Just remember unitary method. That's easy. And if you want to solve by formula, just remember formula: 60 divided by 2 into mar. You know how to calculate mar, isn't it? Just reverse the Snellen's fraction. It's simple. Okay. So visual acuity expression, there are a lot of things. Just I have told you already: decimal system, mar, var, logMAR, Snellen's fraction, and sometimes you see magnification requirement. It means basically whatever the value of mar, whatever value of mar in that context. If you want to make that 1 minute of mar as 1 minute of arc as a resolving capacity, that unit you have to put there is magnification requirement, but it's not that much used in clinical cases. Okay, see, this is the case. Standard visual acuity, not I am not telling you that visual acuity till which achievable. It's always greater than is standard, because in I think human has a capacity of 6 by 2.7. I think I have read it in Adler's Physiology of Vision, but I'm not sure. I think that's what the range. But you have to understand standards mean that we want to achieve. If we want to achieve 6 that means 2020, which means var is 100. At the same time logMAR is 0. At the same time decimal fraction is 1. At the same time mar is 1. At the same time cycles per degree is 30. So that's very important. What is the standard? Sometimes MCQ comes frequently. Okay, see, this is the chart I love. If this is Snellen's chart, then see decimals, just divide it. Whatever get, you get. 20 by 20 is this. 20 by 10 is 2. Just divide it. Mar, you just inverse this. Okay, you just inverse this. Isn't it mar? And you put that mar into log. Log base. Log base 10. And whatever it comes, it's log. Okay, it's log. Var means 100 minus 50 log mar. See, if vision gets better, var gets better. Cycles per degree, it's very simple. Just 60 divided by 2 into mar. Can you see it? Let's take an example. Whenever mar is 2, it's 15. Now it's get double. It's 1 half. Now it's get double when it get half. So it's simple, isn't it? It's very simple. Half, isn't it? It's very simple. And you have to know how to convert this unit to this unit, or to this unit, or to this unit, not in sequence. If someone gives decimal, you can convert this into this. Just remember, these things are very important. Okay, just convert one unit to another unit. Very important. Okay, just remember, which is very important, Snellen's fraction, decimal, var, mar, cycles per degree. These are very important units. Okay, cycles per degree, just don't trick it. Just don't remember this formula 2 into mar. Just try to remember how it actually made, and by unitary method, you will never forget. Okay, just remember these few things. Okay, again, my reference is this. I'm sorry that I'm going slow, but I think it's very important to know visual acuity as an optometry student so well that you can understand it to your bone. Okay, finally, my reference is again Professor Dr. George S. Marriage, my favorite book and my favorite author. So Bistan, cheers.